data. And what I would want, what I mean by that general rule is the 68, 95, 99.7 rule. Okay, that 68 is within 1 standard deviation, 95 within 2, 99.7, or the majority, or in general, 99.7%, right? So that's the rule that I'm after there. What's the total value underneath the bell curve? Surprise, surprise, 100%. For normal distribution, what percent of data is less than the mean? That'd be 50%. 50 greater. Now, most popular shoe size reflects the mode, right? Mode is the one that the number that occurs most often. Draw a normal curve. So you're supposed to do that. Let me fast forward to that. Okay, so I'm just going to go done, right? So yeah, just a curve, and you put the values underneath. You don't have to have this part here that I'm pointing at. Don't worry about that. But the values, percentages, and in this case, it's a mental math type of scenario. It's not, doesn't have to be that detailed. We won't stress over it. So just give it a 1 mark for that part. And then this one should have said state the value of data at, right? Should have said at -3. So 3 standard deviations to the left, right? So that'd be 43 centimeters. At 1 standard deviation, like positive, right? That's right here, 1 over to the right. So that's 49 centimeters. Percent, now it's different. The percent of data less than 2 standard deviations. So you got to go, right? So anything less than 2, you want to be using your graph if I ask you to graph. If you use Normalcdf, that's fine, but it will be different, right? It will be different, slightly different. Then you have between -2 standard deviations and 3 positive. So right between here, between 44.5 and all the way to 52, right? So that is what you want. So either add everything up, or you find what's not included, right, on the edges there, and subtract that from 100. Regardless, you get this. Percent of data that falls between the mean and a -1 standard deviation, it's 34%. That is greater than 50.5 centimeters. So this is 50.5. Oops, you can see that. That's 50.5. So it's 2.5 is comprised in that section. Data that falls between 44.5 and 49. So that's between here and there. So that's 68 and 13.5, right? So that's 81.5. And then state the mean for the data on the table. You have to use L1 and L2 to get this one right, okay? So 46.17, the standard deviation is 2.5, and the sample size is 18, because, right, you're including 18 samples basically in this scenario. Okay, so this is going to be out of 16 because I gave you 1 mark for the actual graph. So, oh wait, hold on. It is 15 because we canceled the first one, right? So we make it out of 15 after all. Okay, all right. Name and last name. Pass it forward. Get your notes out. Let's have some fun with more stats. Yeah, go ahead. I will show you how to do standard deviation by hand at the end. Okay, I don't like to start with it because it might overwhelm some of you. Don't want that. Page 18.
Yes, the one you recorded for the I'm going to save that and then slow it down. Write it down, put it in. Alright, open phone.
That's why you write it down.
So I don't know if you got the message over Google Classroom that the quiz is on Monday. What I'm going to do is I will push everything over a little bit. So I'm going to do quiz, still recording, so there. Quiz Tuesday, test Thursday. So everything goes over one, okay? There's a test next week. Yeah. Yeah. Yeah, we'll figure it out. Maybe in the morning during essential. Yeah, okay. So just note the quiz day. Just make a note of the quiz day, which is Tuesday next week. Okay. Let me just go and write that on the. All right. Go to page 18, please, and we will finish that question. And then I will ask you to do a few of your own. Okay. So page 18 in your notes. Everybody, let's go. So we're still dealing with the potato chips over on 16. So we actually graphed this just to help us out, just to come back and check, does it make sense when we use Normalcdf and inverse norm? And remember that every single value has a z-score associated with it. Okay? So what do the z-scores tell us? How many standard deviations from the mean you are. Okay? So if I give you a potato a mass of 260, you would know it's 2 standard deviations to the right. It's actually on the heavier side, right? And so forth. So let's go back to page 18 here and continue our journey. Page 18, okay? That's the last thing we did. Or we finished H, now we've got to do the rest. Determine the z-score of a bag that is heavier, right? The z-score of a bag that is heavier than 55% of the bags produced. How would you do this? This is a very difficult one. This isn't just a slam dunk, just do one thing and you're done. Okay? So let's put it this way. Let's do just a curve like this, and let's see what we know right off the bat. Okay? The first thing I want you to think of is that along the x-axis we have our weights, right? And every weight has a z-score that goes with it. So what weight are we looking for? A weight that where heavier than 55% of the bags. If you found the weight that's in the middle, that's your average, you would have 50-50, right? So where would you have to move that one? Where would the value be, here or here? It would be here, somewhere in here. So we're just going to make our line and say that 55% is on the left side, right? This weight right here would make it so that it's heavier than 55% of bags. So this is going to give us, we want that score. What is that? And let's follow along. This score will also have a z-score that's associated with it. Because remember, every value has a z-score that goes with it. Does that make sense? Okay, so I'm not jumping to the z-score. I'm going to figure out the value itself first and foremost. Okay, or hold on. I'm going to try to make this as easy as possible. I want the z-score. So this is what I'm going to do. Inverse norm, because they're not asking us for percentage. So we're not interested in normal CDF. Okay. No, inverse norm wants the percentage of values to the left of the one you're interested in. So we have that information. So that's 0.55. It needs to be stated as a decimal. And what should I put here? Mean and standard deviation, right? The mean in this particular case is 250 and the standard deviation is 5. We're going to get that. Let's go ahead and find out what that is. So grab your calculators and let's have a go at it there. Inverse norm, 0.55, 250, and 5. So that weight would be 250.63, and we are dealing with grams, right? But we want the z-score, right? Watch this. If I'm asking for the z-score, what's my mean? 0. What's my standard deviation? You are listening every once in a while. That's good. So second vars, I'm going to call inverse norm. I'm going to go 55%, 0, 1, and that is 0.13. Does that make sense? Yeah.
For calculating the z-score, do we have to use that inverse norm thing, or can we use the z-score formula? Because now we have the specific weight there. So can we do 250 take away 63, take away 250 divided by the standard deviation?
What do you think? Can you use that formula that I gave you? That's what Francis is asking. Can I just use this one? It better, right? It better give you the same answer. I'm just showing you a different way of doing it. So let's try. So this is my z-score. Before we do the calculation, folks, does that make sense? A z-score is 0.13. So it's positive, right? Just a little bit positive. So we know it's above the mean. And think about a weight of 250, right? If you go back to the original, 250 is right there. So it makes sense that if you're just over it, that your z-score will be 0. Right? Like just a little bit over. So that is confirmed. We're good. We're on the right track. Or, right, we can use the formula. Z is the actual score minus the average divided by standard deviation. And we really hope. Do you think it's going to be exactly the same? It hasn't been, right? Like the percentages do not add up the same, but it's going to be very close. And if you show me the work, I really don't care how you get there. Okay, so this is we know this is going to be 0.63 divided by 5. Oh, look at that. Right, which is approximately 0.13. Same z-score. So you know what? If you saw that connection, you're like, wait a minute, why don't I just use that formula? Way to go. You're seeing that everything we're doing is actually somehow connected. Nothing that I've been teaching is isolated from something else. The range, you could bring the range into standard deviation. how spread the data is, all of that, that's still, everything is kind of jiving here. Okay, let's keep going. You know what? I want to pick your brain a little bit. Can you try to do J on your own based on what I just did here? You have to read carefully and not be scared of making a mistake. As soon as you're scared of making a mistake, you're fighting an uphill battle, right? So just read it. Try to do what I do. Try to draw a bell curve. It's like, what am I given here? Where am I located? Question? Okay. So I'm going to pause that here and okay. Let's put this to the test here. Determine the z-score of a bag that is lighter than 31% of the bags produced. The wording is very tricky. I'm trying to see how I can reword it, but the bag is lighter than 31% of the bags produced. So the idea is that if it would be in the middle, right, it would be lighter than 50% of the bags produced, right? So you want to be somewhere over here. This is the value that you're after, and this would be your 31, right? Because at this place you'd be lighter than 31% of the bags produced. And there's a z-score that's associated with it, and that's the only one that I really care about, right? Ultimately, that's what the question is asking for. So what's the problem with inverse norm? It needs the percentage to the left, right? So this would be 69%, right? So that's 0.6901. Okay. Celebration there, or what? Second vars, inverse norm. And that's 0.50 if you round that. That's the z-score. Okay. Because you round it. Did you find the value and then use the z-score formula? Yeah, that's fine. I will say that it is fine to, if you did this step, right? You found the value itself. What is it, by the way? 247.5? 52. And then you use the formula, whatever works is fine. Okay. What about this one? Determine the z-score of a bag weighing this much. Here, you don't have options, right? You need to use this one. There is no other way of doing that, right? So it's 259.25 minus the average is 250 over 5. They don't give you enough information to do anything other than that. You can't use Normalcdf, right? They're not asking you for percentage. Inverse norm, you don't know the percentage to the right or left, so you're stuck with this, right? So we have 9.25 divided by 5, and that's 1.85. No units, okay? Do not put units in that, because that would be wrong, okay? It tells you, let's interpret that, explain. If I ever ask you to explain, okay, a bag with a mass of 259.25 grams is 1.85 standard deviations above or below? Above the mean. Because I will ask you at some point to explain. Why is it above? Because it's positive, right? If your z-score would have been negative, then you would have had to say it's 1.85 standard deviations below the mean. Okay. There's a worksheet that's right after this. Okay, so pages 19 to 20. And if I give you time to work in class, I expect you to work in class. So if I see you on your phone, you will hear from me. Okay. So 19 to 20, it says normal CDF inverse norm worksheet. So this stuff will be on the quiz next week. So make sure you go through this and try to figure it out. You'll have to choose between normal CDF inverse norm. You'll have to find z-scores. You'll have to do all of that stuff that we've just talked about. So try to use the examples I've given you before you ask questions, but you can gladly ask. If you're stuck, ask. Okay? Got it? Friday, we'll take it a little easier. Instead of me just pushing through it, I'll give you time to do 19 to 20 right now. And I will give you another worksheet to do over the weekend. Okay? So I'll pause this here. Good job, guys. There is at the bottom of 20, there's the homework that goes with what we did today. The workbook, I will have to post that key. There's workbook and textbook, so the more you need, the better. The more you work through, the better, I should say. And this answer key I will post as well. I don't know, I might have it on the video here if you want to watch that. I saw you working, so I didn't want to interrupt that. But here's just a few answers. I will scan it, post it as well. I don't know if you remember your answers. And if you use a different method, you might have a slightly different number, and that's fine, right? As long as you show me your work there. All right, so remember to try a few questions at home. If you have to choose between sleep and homework,